Welcome to another video segment about binary number system. But on this video, we are going to talk about subtraction of unsigned binary. So there are some rules that we have to follow whenever we operate on subtraction about unsigned binary. And these rules are only applicable for subtraction on unsigned binary. So let's enumerate these rules. Rule number 1, 1 minus 1 is always 0. Rule number 2, 1 minus 0 is always 1. Rule number 3, 0 minus 0, that is 0. And rule number 4, 0 minus 1 is borrow with carry 1. So the most interesting part here is the rule number 4. So when you have 0 subtracted with 1, you have to look for a number where you can borrow, and then you include a carry 1. Okay, so let's have some examples of this. So let's say we have this given. So now let's try performing subtraction on unsigned binary by following these rules here. Okay, so 1 minus 1, we have 0. And then 0 minus 1, rule number 4, it says here, borrow with carry 1. We cannot really subtract 1 to 0. So we have to borrow from the nearest neighbor on the left side. So this is the nearest neighbor on the left side. So we have to borrow here. So this becomes 0. And we have to add 1 and 1. So that is now the carry. So when you borrow from the left side of the nearest neighbor, so you have to carry twice, the borrowed number and the carry bit. So that is the meaning of carry 1. Okay, so now let's perform the subtraction. 1 minus 1, that is 0, and what is left here is 1. Because this will be cancelled out also. Okay, then 0 minus 1, again we have to borrow, but the nearest neighbor is 0, so we have to look for another nearest neighbor, which is this one. So we have to borrow from here, so this becomes 0, and we have to add double 1, and then we have to borrow here, so this becomes double 1 again. And what is left here, 1 minus 1, that is 0, and what is left is just 1. And point 1 minus 1, that is 0. 0 minus 1, we cannot do that, so let's borrow from here. This becomes 0, and we have to add 2 ones at the top. And then 1 minus 1, 0, what is left is just 1. 0 minus 0, 0. 1 minus 0, 1. And then this is 0, 0, and the rest are zeros. Alright, so let's check the equivalent of this in decimal. So this is basically 46.625. And this one is 35.875. Okay, so let's check after subtracting this if the answer is the same as with the answer we have on the binary. Okay, so 5, that is 0, so this becomes 5, and this becomes 7 point, this becomes 0, and then this becomes 1. Alright, so we have 10.750. Okay, so let's check. So this is 50, and this is 25. So 0.25 plus 0.50, we get 0.75. So meaning on the fractional part, we have a correct answer, 750, because this is 750. If we are going to add this one, or 0.75. Let's mark the numbers here, 1, 2, 4, 8, and then we cancel those with 0, and what is left is just 8 and 2. So 8 plus 2, that is 10. So this is 10.75, which is equivalent to our answer here. So let's have another example. Zero minus zero, that is zero. 0 minus 1, it can't be, so we have to borrow from the nearest neighbor at the left side. And this is the ideal bit that we can borrow. So this becomes 0, and we have to carry twice. 1 minus 1, that is 0, and what is left is 1. Because this will be cancelled out, because 1 minus 1 is 0. Okay, then 0 minus 0, we have 0. 1 minus 1, 0. 0 minus 1, so again we have to borrow. This becomes 0, and 2 carries at the top. And this will be cancelled out. So what will remain is just 1. 0 minus 1, again we have to borrow. And since this is 0, we have to borrow from the next neighbor. So we can borrow from here. This becomes 0. And carry at the next bit at the right. And then borrow from here. So carry at the next bit at the right again. So 1 minus 1, that is cancelled out. So what will remain is just 1. Then 1 minus 0, that is 1. 0 minus 1, we cannot do that. So we have to borrow from here. So this becomes 0. And we have to add 2 ones at the top. Again, this will be cancelled out because 1 minus 1 is 0. So what is left is just 1. And then 0 for the rest. Okay, now let's try to check our answer if it is correct. So I believe that this is 53.50. And this is 23.25. And then if we perform subtraction, so this becomes 5. And this becomes 2. And then this becomes 0. And 5 minus 2, this becomes 3. So our answer is 30.25. Okay, so let's check if this is equivalent to 30.25. So obviously, the fractional part here is 25. This is 0.50, 0.25, and the last one is 0.125. Okay, and since this bit and this one is 0, so we will only count this bit at the middle. So that is 0.25. So that is why we have 25 here. And then let's mark the numbers here. This is 1, 2, 4, 8, 16. And we have to cancel the numbers with 0. We have to cancel this one. And what is left are just 16 plus 4, that is 20. 20 plus 8, 28 plus 2, that is 30. So meaning this is 30 and then 0.25. So that is equal to our answer in decimal. For our last example, we will try the first given is smaller than the second given. So the first given will be 0, 0, 1, 0, 0, 0, 1, and 0.011 minus 1, 1, 0, 0. So let's try subtracting this. We know that we are dealing with unsigned numbers. And since unsigned numbers do not have any sign, it is not negative nor positive. They don't have sign. And as you can see, the second given is larger than the first given because the most left side is 1. And we know that the most left side is 1 to 8. Where on the first given, so this is 32, 16, 8, 4, 2, and 1. So that is why we can tell immediately that the second given is bigger or larger than the first given. So we can get the decimal form of this so that it is very clear to us that the first given is bigger than the second given. So this is 56.375, and this one is 205.625. 56.375, 205.625. Now let's try subtracting these numbers. So let's try solving this. 1 minus 1, that is 0. 1 minus 0, that is 1. 0 minus 1, we have to borrow. So borrow from the nearest neighbor. So the nearest is also 0. So we have to jump next on the left side. And we turn this to 0 and carry 2 bits at the top. And then we have to cancel out the first one because we have to borrow it and put it right here. And we have to cancel this. So what is left is just 1. And 1 minus 1, that is 0. 0 minus 1, again, you have to borrow from here. This becomes 0. And we have to put 2 carry bits. Okay. Then this will be also cancelled out. So what is left is just 1, 0. And then we have to borrow again. This becomes 0. And then carry 2 bits. Borrow here. Then carry 2 bits again. And then this will be cancelled. What is left is just 1, 1, 0. And then 0 minus 1. So there are no numbers left on the left side that we can use for borrowing. That is why we stop right here. Meaning we cannot really proceed solving this problem because we have a negative result, and negative result cannot be done on unsigned binary. We can only solve this if the second given was the first given and the first given was the second given. We cannot really solve this. It will turn out that the result is negative. Okay, so that ends this video, and thank you for watching.